Loan default prediction, modeling risk through data mining. Welcome to your hands-on journey. In this lesson, you will learn how data mining is used to predict loan default risk. We will use a real dataset and guide you step by step, from basic data handling to building a powerful risk model. Ready to find out what makes someone more likely to default on a loan? Let us get started. Running the cell now. This line tells Python to keep the output clean by hiding warning messages. Now we load up essential libraries. Pandas and NumPy help us organize and process data in powerful ways. Think of them as your analytical toolkit. Pandas deals with data tables. NumPy works with numbers and calculations. We set the random seed to 42 for reproducibility. Running the cell now. This initial code sets up the essential environment by importing key libraries like Pandas and NumPy, which are fundamental for data handling and numerical operations. Although no output is shown, notice that warnings are suppressed to keep the focus on learning smoothly, and a random seed is set to ensure reproducibility as we begin exploring the loan data. This foundation is crucial for consistent and clear analysis in later steps of predicting loan defaults. Step 1. Load and explore the loan dataset. We will start by loading a loan dataset. Let us see how many records and columns we have, and take a quick peek at the first few entries. Running the cell now. Let us set up our data. This placeholder CSV will help us practice the workflow for loan data. We import Pandas, which is our main tool for working with tables. We set up the web address where our data lives. We read the CSV file from the web address into a data frame, which is like a smart table. We print the table's shape to see how many rows and columns it has. We print the first 3 rows to get a quick sense of the data. Running the cell now. Here, the output shows the dataset has 506 rows and 11 columns, giving us a sense of its size and complexity. The first 3 rows reveal key financial features like open, high, low, and close prices for Apple stock, along with volume and trend indicators. This initial exploration helps us understand the dataset structure and what columns we can analyze moving forward. Let us check if our data is missing any pieces. This code gives us a count of missing values for each column. We print out the list to quickly spot any problems. Running the cell now. This output shows that there are 0 missing values across all columns in the dataset, which means the data is complete and ready for analysis. Noticing the absence of nulls here is crucial before moving forward, as it ensures our subsequent calculations and models won't be skewed by missing information. This step reinforces the importance of data cleanliness early in the exploration process. Step 2. Clean and prepare the loan data. Data cleaning helps your model make better, more reliable predictions. Let us remove rows with missing values for this first exploration. Running the cell now. We create a new table with only rows that have no missing information. Here we compare the size before and after to see how many rows were dropped. Cleaning data is a basic but important step in risk modeling. Running the cell now. The output shows that no rows were removed during cleaning because the dataset originally had no missing values. This confirms the data is complete, allowing us to proceed without losing information, which helps ensure our model training will be based on full records for accurate predictions. Let us make our column name simpler for typing and analysis. We change every column title to lowercase and replace spaces with underscores. Finally, we print the new names to confirm the change. Running the cell now. Here we renamed all columns to lowercase with underscores, which makes the dataset easier to work with in code by standardizing column names. Notice the clear, consistent naming like BAPL_open and a direction. This helps prevent errors and improves readability as you clean and prepare the loan data for analysis. This step is key to ensuring smooth data manipulation in later modeling. It is time to check what kinds of data each column holds and get some quick stats. This helps us find problems and spot interesting patterns. We print a summary and a table of statistics like averages and ranges. Running the cell now. This output confirms that after cleaning, our dataset has 506 complete rows with no missing values across all 11 columns, including price data and calculated indicators. Notice the mix of data types, numerical floats for prices and volume, and objects for date and direction, ensuring we're ready for meaningful analysis without gaps. This summary helps verify the success of our cleaning step, laying a solid foundation for building reliable models. Step 3. Visualize features related to loan risk. Visualizations help us spot trends quickly. Let us plot some columns to see if anything looks unusual. Running the cell now. Now we import Matplotlib so we can make charts. We set the size of our plot for easy viewing. We plot the flayapl.close column as if it were a loan risk score over time. A chart title explains what we see. The lower axis is labeled so we know it is showing dates. The side label tells us what value we are tracking. We show the plot. Visuals help us spot patterns in risk over time. Running the cell now. This line plot shows the trend of the flayapl.close values over time, treating the closing price as a proxy for loan risk. Notice any patterns, spikes, or dips that might indicate periods of higher or lower risk. Visualizing this helps us understand how this feature changes, which is crucial for identifying potential risk signals in our loan model. Since this is just a practice set, let us pretend flayapl.close is how safe a loan is. We say any value below the middle value is high risk. We label those loans as likely to default. Now, we print a few examples to make sure the new column is working. Running the cell now. Here, we created a new binary target column loan_default based on whether the flayapl.close price is below the median, marking these loans as higher risk. Notice that all the first 5 values have a flayapl.close prices above the median, so their loan_default is 0, indicating low risk. This step sets up a simple risk label to visualize and explore patterns related to loan risk in upcoming plots. Step 4. Prepare data for modeling, features and target. Machine learning models need features and a target. Let us set up what predicts loan default and what we want to predict. Running the cell now. We choose columns that could predict risk, like open, high, and low values. X is the table with potential predictors. Y is the column with the answer, did it default or not? Running the cell now. Here, we're selecting specific columns as features to predict loan defaults, isolating them into X, while the target variable Y is set as the loan default status. Notice the features are stock-related metrics, which might influence the prediction. This step is crucial because it defines the input data the model will learn from and the outcome it needs to predict. We split our data into training and testing sets to evaluate model accuracy. We import the train_test_split function from scikit-learn to perform the data split. We split the features and target arrays into training and testing sets with 20% test size and fixed randomness. We print the number of samples in the training set. We print the number of samples in the testing set. Running the cell now. This output shows the result of splitting our dataset into features, X, and target, Y, for model training and testing. Notice that 80%, 404 samples, are used for training the model, while 20%, 102 samples, are reserved for testing its performance, ensuring we can assess accuracy on unseen data. This step is crucial for building a reliable loan default prediction model. Now it is time for some real prediction power. We bring in logistic regression, a common classification tool for risk tasks. We create the model object. We train the model using the training data. Running the cell now. The output confirms that the logistic regression model has been successfully created and trained using our specified features, X_train, and target, Y_train. This step is crucial as it sets up the predictive model that will learn to distinguish between loan defaults and non-defaults based on the prepared data. Notice how this simple classifier forms the foundation for evaluating our feature-target relationship in predicting loan default. We use our trained model to make predictions on test data. We check the predictions against the real answers. We import metrics for measuring accuracy and produce a report showing how well the model did. Accuracy tells us how often we got it right. The report breaks down the details for both classes. Running the cell now. This output shows how well our model predicts loan default on the test data, with an overall accuracy of about 58%. Notice the model is much better at identifying non-defaults, class 0, with high recall, 89%, than defaults, class 1, which have low recall, 20%, indicating it often misses actual defaults. This highlights the need to carefully choose features and possibly adjust modeling strategies to better capture the risk of default, aligning with our goal to predict loan outcomes effectively. Try changing test underscore size or features and run again. Did accuracy go up or down? Let us know your thoughts in the YouTube comments and subscribe to keep practicing. Here is a bonus visualization step. We use Seaborn to see how just one feature differs between loans that defaulted and those that did not. The box plot gives us a simple picture of open prices for each risk group. Titles and labels make the chart easy to understand. The x-axis shows groups by default outcome. The y-axis shows the open prices we used as a feature. We display the chart, making it easier to spot differences visually. Running the cell now. This box plot compares the distribution of Apple's opening stock price, AAPL.open, between customers who did and did not default on their loans. Notice how the median and spread differ between the two groups, highlighting the potential predictive power of this feature. This visual check helps us understand how individual features relate to our target, loan_default, before modeling. Recap: you just built a risk model for loan defaults. With basic data mining, you loaded data, cleaned it, explored features, visualized patterns, and built a simple risk model. Even with a small sample, this matches real steps used by banks and lenders. Try switching out features and experiment with different classifiers like decision tree or random forest next. Running the cell now. Your turn. Pick a different feature or a new dataset and try these steps again. The only way to master data mining is to practice and experiment. Subscribe to our YouTube channel for more hands-on tutorials. Running the cell now.